Questions 7 and 8 from the homework are also very similar to the previous question. And here they use the correct wording because they ask for the average reaction rate, right? So to find the average reaction rate, they give us the reaction and they tell us our initial concentrations, and then they say after 75 seconds, right, the hydrogen concentration has gone from 0.45 to 0.34. So we can't do anything with nitrogen really because we don't know the concentration of nitrogen after 75 seconds. So we'll just work with hydrogen, right? So we're going to find the relative rate first, right? Just with respect to hydrogen, and that's going to be our change in concentration of hydrogen over our change in time. And it's final minus initial, and hydrogen's being consumed, so we have a negative out in front. All right, so a negative, my final concentration, 0.34, my initial concentration, 0.45 molar. My change in time, final time was 75 seconds, initial time was 0. So basically we have 0.11 divided by 75. So I get the relative rate of this reaction with respect to hydrogen, 1.47 times 10 to the minus 3 molar per second. That is the relative rate with respect to hydrogen. To find the average reaction rate, for that, we would have to use the coefficient because, again, the relative rate will be different for nitrogen, hydrogen, and ammonia. They would all have different rates because they all have different coefficients. So they would be disappearing and appearing at different rates. The average rate, however, would be the same for the whole reaction. So we would take this for hydrogen, right? The rate for hydrogen is 1.47 times 10 to the minus 3 molar per second. And the coefficient in front of hydrogen is 3, which means it's reacting 3 times faster, right? So divide that by 3, and I get an average rate of about 4.9 times 10 to the minus 4 molar per second. Would be our average reaction rate. Right, and you'll notice, I kind of wanted to say this earlier, but when we divide this by 3, we're basically setting this rate equal to the rate of nitrogen, right? Because nitrogen has a coefficient of 1. So the average rate of this reaction also would happen to be the relative rate with respect to nitrogen. Because by dividing this by 3, we're setting our coefficient, basically equal to 1. So the relative rate and the average rate, the relative rate with respect to nitrogen and the average rate would be the same in this case. But we found the rate of hydrogen first, divided by the coefficient to find our average rate of the reaction. For the next question, question 8, this is kind of a little bit, going backwards. I would have done this question first and then gone to 7, but we know the relative rate for hydrogen. All right, the relative rate for hydrogen, we found it as 1.47 times 10 to the minus 3 molar per second hydrogen. Right, to convert this into the rate of ammonia, we would just say, 3 hydrogens in, 2 ammonias out. So we multiply by 2/3, hydrogen cancels. And with respect to ammonia, we're going to see the relative rate with respect to ammonia, about 9.8 times 10 to the minus 4 molar per second for ammonia. So question 8 should be very similar to a lot of the questions or a few of the questions we did in class this week.